Good morning to all. So the next session is we are going to discuss about the typical embedded system. Okay. So this is the general block diagram of a typical embedded system. Okay. So the brain of the embedded system is the system core. System core. Okay. So the interfaces here are first one is the input ports. So we call it as a sensor. We need to acquire some data from the external world, and the system processes the input and it produces the output, and the output will be sent to the output ports to the outside world via the actuators. And there is a memory. Okay, so the memory is used for storing the embedded firmware or software. Okay, and this system core can be, it can be either FPGA, ASIC, DSP, or SoC. FPGA stands for Field Programmable Gate Array, ASIC Application Specific Integrated Circuit, DSP Digital Signal Processor, and SoC System on Chip. Microprocessor, it can be processor or controller. And there is a communication interface. So that means, so if we need to transmit this, that process data from one system to the another system, we need a communication interface. Okay. So this is the general block diagram of an embedded system. Okay. So first we will discuss about the core of the embedded system. The core of the embedded system falls into these four categories. Okay. So that means that I already told you it is the brain. It is the brain of an embedded system. So that means you cannot replace the brain. You cannot, even though you can replace any part in our body, but we cannot replace the brain. So that means it is the brain of an embedded system, the core. It can be falling into any one of these four categories. First one is the general purpose and domain specific process. Second one, PLDs, programmable logic devices. Third one, application specific integrated circuits. And fourth one, COTS, commercial off the shelf components. Okay, first we will discuss about the general purpose and domain specific process. So first we will discuss about the general purpose processor versus application specific, ASIC, application specific instruction processor. So general purpose processor is a processor designed for general computation tasks. Okay. So GPPs are produced in larger volumes and targeting the general market. So due to the high volume production, the per unit cost for a chip is lowered compared to the ASIC or other specifiers. A typical general purpose processor contains an ALU and the control unit. So this is about the GPP. Next one, ASIC, application specific instruction processor. Instruction set processor are the processors with the architecture and the instruction set which can be optimized to specific domain or application requirements, like network processing, automotive, telecom, media applications, or any digital signal processing or control applications. So the ASICs fill the architectural spectrum between the general purpose processors and the application specific integrated circuits. Okay, so some microcontrollers, system on chips, DSPs are the examples of the application specific instruction set process. So the ASICs incorporate a processor and an on-chip peripherals demanded by the application requirement, program, and data memories. We will discuss those in the next session. The first one, microprocessor. So what is a microprocessor? A microprocessor is a programmable device which takes the input and performs arithmetic and logic operations on the inputs and produces the other than input. Okay, it can be a silicon chip representing a CPU which is capable of performing arithmetic as well as the logical operations according to a predefined set of instructions. So the CPU contains ALU as well as the control unit and the working registers. So the purpose of the registers is they can provide as an input to the ALU. Okay, so the ALU takes the input from the registers and it will process the inputs, and the output will be also stored in the registers. The microprocessor is a dependent unit and it requires the combination of other hardwares like memory, timer unit, and interpret controller, etc. for proper functioning. Next one, microcontroller. What is a microcontroller? It's a highly integrated silicon chip containing a CPU, memory, scratchpad, and general purpose register arrays, on-chip RAM or flash memory for program storage, timer and interrupt control units, and dedicated I/O ports. So the basic difference between the microprocessor and the microcontroller is microprocessor is nothing but for the general purpose application, whereas coming to the microcontroller, which is used for a specific application. So simply we can say if a computer is fabricated on a chip, so it is nothing but a microcontroller. So in addition to the microprocessor, just having the memories, timers, interrupt control units is nothing but the microcontroller. So microcontroller can be considered as a superset of the microprocessors. So the microcontrollers can be general purpose or application specific. The microcontrollers are cheap, cost effective, and these are readily available in the market. Now, these are some of the differences between the microprocessor and microcontroller. So you know very well, it's a CPU which is capable of performing ALE as well as the logic operation. So it's a computer fabricated on the chip. It is a dependent unit. It requires the combination of other chips like timers, program and data memory chips. After processing, we need to store the data in memory. That's why it requires memory. Okay. So it's a self-contained unit and it is that doesn't require external devices. So most of the time, general purpose in design and operation, mostly application oriented. I already told you the processor is general purpose and the controller is the specific purpose. And it doesn't contain a built-in IO port. Here it contains the built-in IO port, which can be operated as a single 8-bit or 16-bit or 32-bit port or as an individual port pin. So that means every port, suppose if it is an 8-bit port, which contains 8 pins, so each pin can be configured as either input or output. So the microprocessor is targeted for high-end market where the performance is important. Here, the microcontroller is targeted for embedded market. And this is the limited power saving more options compared to microcontroller, and it includes a lot of power saving features. So these are the some of the differences between the microprocessor and the microcontroller. So that's all for today, and we will discuss the further topics in the next video session. Hope you understand it. Thank you.